Hey guys, this video is on proportional relationship. If you remember back when we learned about ratios, we learned that a ratio is comparison between two numbers, two quantities. So if I had squares and triangles and I asked you, what is the ratio of squares to triangles? Well, right here, it would be 1 square to 2 triangles. Well, what happens if I added another square? If I added another square, maybe I'd have to add another 2 triangles. And my new ratio of squares to triangles would be 2 squares to 4 triangles. And then again, if I added another square, it would come with 2 more triangles. And my new ratio of squares to triangles would be 3 to 6. A proportional relationship shows ratios that are equivalent to each other. This is a relationship because every single time I add a square, 2 triangles come with it. And I know that 1/2 is equivalent to 2/4, which is equivalent to 3/6. Now, for some reason, I took away this triangle. So I added 1 square, it came with 2 triangles. I have another square, it came with 2 triangles. And then I had another square, but it only came with 1 triangle. My new ratio of squares to triangles would be 3 to 5. 3 to 5 is not equivalent to 2/4 or 1/2. That is no longer a proportional relationship. So a proportional relationship is showing that the same pattern. Every single time I add a square, I added 2 triangles. Here's a square, 2 triangles, square, 2 triangles, square, 2 triangles. Those ratios, 1/2, 2/4, 3/6, those are all equivalent to each other. That is showing a proportional relationship. Let's look at a table now. Looking at this table, we want to know, is this a proportional relationship? Some of you guys may immediately notice that we are multiplying by 3. 1 times 3 is 3, 2 times 3 is 6, 4 times 3 is 12, 5 times 3 is 15, and you might go, oh yes, right away this is a proportional graph. Another way for you to look at this is how do we go from each number? So how do we go from 1 to 2? Let me use another marker. How do I go from 1 to 2? Whatever I do right there, because this is proportional, what I do right here has to be what I do on this side. So 1 times what is 2? 1 times 2. Well, if this is being multiplied by 2 to make this jump, then this same size jump on this side must also be times 2. And we do know that 3 times 2 is 6. Yes, that is correct. Let's check the rest. How do I make a jump to 4? I could jump from 1 to 4 times 4, and I can say 3 times 4 is 12. Yes, that is correct. I also could make a jump from 2 to 4. 2 times 2 is 4. 6 times 2 is 12. Whatever you jump to the number, it has to be the same size jump. How do I get the 5? 1 times 5 is 5. Well, then 3 times 5 needs to be 15, and that is correct. So by that reasoning, this is also a proportional table. Sometimes it isn't so obvious that it is multiplied times 3 or multiplied to some number, so you do have to check these jumps to see if it is proportional or not. Let's look at this table. You earn $12 doing chores at home every week, and we're going to fill in this table. So we have different numbers of weeks, and we want to know how much money you earned. So if every week I earn $12, I know right away that this is going to be a proportional relationship, because it's not like one week I earn $12, then another week I earn $8, maybe the next week I earn $15. It's the same relationship every single time. Every single time you do chores for a week, you earn $12. So I can go ahead and fill this in. If I do chores for 1 week, I earn $12. How about 4 weeks? Now you could add $12 for 1 week, for 2 weeks, for 3 weeks, for 4 weeks. You could add that together, or you could do 12 times 4. If we did 12 times 4, we get 48. And again, if this is proportional, then this jump on this side must also work. 1 times 4 is 4. how do we jump? This is a blank, so we wanted to figure out what is the relationship. How do we get to 8? We can get to 8 by making this jump right here. 4 times 2 is 8, which means 48 times 2 would give me this blank. Or we can say, how do I get from 1 to 8? What is the jump between 1 and 8? That is times 8. So 12 times 8 goes in this blank. How do I get to 12? I can't easily make a jump from 8 to 12. I can't easily make a jump from, or I can easily make a jump from 4 to 12 or 1 to 12. Either one works as long as the jump size that I have on this side is the same as the jump size that I do on this side. So we know that 1 can jump to anything. So how do I get from 1 to 12? I'll use another marker. 1 to 12 is times 12. So this jump size needs to be the same. I need to go 12 times 12, which is 144. Last one, how do I get to 16? Can I jump from 12? Can I jump from 8, 4, or 1? I could jump from 8. I could jump from 4 or 1. Just to show you that they're all the same, if I jumped from 8 to 16, that's times 2. So let's see, 96 times 2 is 192. But what if I wanted to make the jump not from here, but from, let's say, from 1? This is times 16. So is 12 times 16 192? 12 times 16. Yep, so it doesn't matter where you jump from as long as it's the same size jump from both sides. Okay, so this is the same size jump, this is the same size jump, this is the same size jump. Okay, so as long as it's the same size jump, you can jump from whatever number you'd like. I want to look at a homework problem that a lot of you guys had a hard time on. To make the perfect cup of hot chocolate, you mix 4 tablespoons of mix to every 2 cups of water. It already filled in the table with what is said on the in the sentence. Complete the table and circle the unit rate. So I have a blank right here. I want to know what goes in this blank. Well, I need to know what is the relationship on the bottom to get to the 7. I can't easily get to 7 from 2, right? No, so I need to find my unit rate. A unit rate is a special type of ratio that has the number 1. So what did I do to get to this 1 from this 2? How did I go this way? I'd have to divide by 2. So if I divided 2 divided by 2 to get 1, this relationship is the exact same. 4 divided by 2 is 2. So now I found my unit rate right here. What's neat about a unit rate is that it has the number 1. And what we know about 1 is anything times 1 is that number. So I could use this 1 to jump to any number I want. How do I jump from 1 to 7? I multiply times 7. So if I'm making this jump here, I got to make the same size jump up here. 2 times 7 is 14. Now I have a blank at this below the 16, so I have to figure out, well, how did we get to the 16? What is the relationship between these top numbers and 16? Can I make a jump from 14? Not easily. Can I make a jump from 4? I could. If we jump from 4, we know that 4 times 4 is 16, so I have to make the exact same size jump. I have to start from this 2. 2 times 4 is 8. Okay, last one. I have a blank up here. I need to know what is the relationship to get to this 11. Can I make a jump from 8? Not easily. 7, 2, or 1. Well, I can make a jump from 1. 1 times 11 is 11. So if I make this same size jump from this 2, I must also multiply times 11, and I would get 22. Okay, so we know this is proportional. Another way for you to check this to see we could do 1 times 2 gives me 2. 2 times 2 gives me 4. 7 times 2 gives me 14. 8 times 2 gives me 16. And 11 times 2 is 22. So I know that they're both proportional. One last thing I wanted to show you is how we can tell whether a graph is proportional. The two most important things about a proportional graph is that it is straight and it starts at 0. So it needs to be straight, it needs to start at 0, 0. So 2 examples. Starting at 0, 0, straight line out. This is a proportional graph because it starts right here at 0, 0 and it is straight. Let's do another one. How about this? Well, if I were to draw a line to connect my points, it would be straight and it would start at 0, 0, so that one is also proportional. Now, it doesn't matter how steep or how flat your line is. It could be this, for example. That's also proportional. It could be this, super steep, for example, but they all start at this 0 and they are all straight, so it is proportional. This one, you may want to say looks proportional because it's so straight, right? But it doesn't start right here at 0, 0, so it is not proportional. This one, you might say is proportional because it starts at 0, 0, but it is not straight, so it is not proportional. I hope that helps. That is a review on proportional relationships.